Life has been innovating for 3.8 billion years, resulting in time-tested and proven strategies, designs in continuous circular loops. A circular economy already exists. It's all around us. And we humans, we just need to learn how to fit into that. So if other life forms have been doing it for eons, what better models are out there to learn from? My name is Saskia van the Muijsenberg. I'm the founder and director of Biomimicry NL, and I'm thrilled that you're here to watch my talk. And so you must be here because you're interested in innovation. But where does innovation come from? Well, for most people, it's a process that is happening in our brains when neurons spark because of a brainstorm or taking a shower. It's where the magic of new ideas happen. And of course, we humans, we have been very innovative, but we're not the only ones, and definitely not the first ones. As said, life has been innovating for 3.8 billion years. And some remarkable innovations happened because of other organisms. Think about inventing photosynthesis, taking energy from the sun and turning that into food for yourself. Or being able to fly across oceans, tens of thousands of kilometers, on just 1 tablespoon of sugar. Today, I'd like to talk about biomimicry and circular economy because I think the two of them make a really strong combination. And one definition that you often hear of biomimicry is the conscious emulation of life's genius. And those words have been chosen very carefully. Conscious with the intent of asking nature for advice to all sorts of challenges we in our society are facing. Emulation, the underlying principles that you can distill from nature's technology. And life's genius is not just the ingenuity of innovation happening in nature, but it's also the elegancy and the sustainability of lots of those innovations. And it's being applied in many different sectors. In here you see in the built environment, buildings that took inspiration from termite mounds to create passive ventilation systems so there's no requirement for the air conditioning. Or wind turbines taking a clue from the bumps on the humpback whale to create wind turbines that are still very effective in places with not so high wind speed levels. And there's so many scientists looking at that process of photosynthesis to create better solar panels. Also, I wanted to talk about circular economy. And you are probably very familiar with the butterfly diagram of the Ellen MacArthur Foundation, but you find here a more simplified form where we have this technical loop, the technical nutrients of all the stuff that we create and we want to keep in the loop to last longer, and so we can minimize the waste coming out of it, and the biological nutrients that are potentially biodegradable and can cooperate in harmony with the rest of nature. And the premise of the circular economy is that it can help find a solution for businesses to operate within the carrying capacity of our planet Earth. And that is very well described by Kate Raworth in her donut economy model. So this green band is the bandwidth which is safe for humanity to operate in. But currently, you can already see there's an overshoot. We're going over that ecological ceiling. We're going over the threshold of that carrying capacity in many different ways. And the most prominent, of course, is climate change, but also loss of biodiversity, the limits to phosphorus, and also land conversion. And then we're shortfalling on some social dimensions that you can see in the middle of the donut. So what we see is that if I see more and more businesses that want to transform to the circular economy, but still we're in the very pre-development phase. It is not really integrated in strategy. You see it in most cases as side projects. We're experimenting, and we are still before it actually takes off. And I think that has to do because of some barriers to the circular economy. But looking at that circular economy, of course, it's all about zero waste. And this is why it's easy to see how biomimicry is one of the schools of thought to a circular economy, next to Cradle to Cradle and industrial ecology. Because in nature, there is no waste. A fallen tree is food for bacteria, for fungi. And in fact, you could say that a circular economy is an example of biomimicry at a systems level. But as said, there are some barriers for CE transformation while we're still in the pre-development phase. And one of them is that in practice, nature is really taken merely as a metaphor, which allows business to continue as usual. If I talk to people and I talk about ecosystems, they usually think about the business ecosystem, but they don't make the link to the natural ecosystem. And that can be a problem. We also see that those practices in the CE are framed within the market or economic logic, and they do miss that connection with the biophysical ecosystems. And also, there is a lack of a normative aspect for sustainable development. At a macroeconomic level, people understand the CE. We cannot overshoot the carrying capacity of our planet Earth. But what does that mean for an individual business? How do you know what you can do? That sort of normative link is missing. And as I said, many of the practices of CE are quite marginal. It's usually side projects, and even more, they focus on recycling. Recycling has almost become synonymous for CE. And that is a problem because recycling doesn't require a fundamental change in business practice. It does not trigger the profound changes to our understanding of how our world works and what is considered normal or legitimate. So, how can we combine those two? Here are some examples of biomimicry applications that help to save lives, that help to move to regenerative businesses. And the first one I like to talk about is Ornilux from Arnold Glass. Ornilux is a solution to the problem of many birds collapsing to our glass buildings. And you will be shocked to learn that every day in the US, they research for the US and they estimate the same for Europe, every day 250,000 birds collapse and die because of our glass windows and the reflection. They can't see, it's a reflection and think they can go through it. But birds don't fly into spider webs. And that is because spiders have a fiber in their silk that is reflecting in the UV spectrum that we humans cannot see, but the birds can. And it helps the spider because otherwise its home would be destroyed. And Ornilux took inspiration from that. They created glass that for us it's perfectly normal to see through, but the birds, they see the weaving of the spider web within it, saving lots of bird lives. Doing biomimicry often starts with asking how nature accomplishes a function. So have you ever thought about how nature creates color? And if you see all those beautiful colors in the peacock, it is quite hard to imagine that in fact a peacock has only one color. It's completely brown. It only has one pigment, melanin, the same as we have in our skin. But we see all these different colors because the layers of the feathers, they have so many layers in different, and there's different sizes between them, that they refract and reflect the light in different length waves that we pick up, so we see this color. This is what we call structural color, and you can find it in butterflies, you can find it in many birds, and there are now companies mimicking, using the structure to create color. for instance, in our fabrics. So we don't need to dye them anymore, and no heavy metals will end up in the environment. And I think that with 3D printing, if we start to understand what the structure needs to be, and we can start printing at the nanoscale, and we know what is the structure for yellow and for blue and for green, then we can apply that to many 3D printed things, like cars and buildings and whatever your imagine brings you. So it's a true platform technology. Well, in fact, nature uses shape rather than material, like the peacock. And in this case, also to create multifunctionality. And one material, like the chitin of the beetle, achieves all the same functions as a potato chips bag. But for potato chips bag, we need at least 4 different layers of plastic to achieve different functions. So the beetle, when it wants to create color, it uses structure, like the peacock. When it wants to create breathability, it creates a pore out of the same material. If it wants to be abrasion resistant, it uses a plywood structure to achieve that function. So what if we could create our chip bags with just one material, achieving different functions? How much easier that would be for recycling further down the road. And Warner Babcock is a company that is really heavy into green chemistry and came up with beautiful solutions already. And furthermore, the Wyss Institute, they have created a material called Shrilk that mimics the chitin of the insects. And it's a low-cost, biodegradable, biocompatible material and may provide an alternative to plastics. And Shrilk is similar in strength and toughness to an aluminum alloy, but it's only half the weight. And shown here is a replica of an insect wing which was made with that new material. Another example that I love is how nature deals with the surplus of CO2. Coral reefs, they are made out of carbon, out of CO2, like many scallops and shells. And they create the hard material through a self-assembly process in ambient temperatures. And Blue Planet is one company that took inspiration from the recipe of the coral reef. And what they do is they collect CO2 from smokestacks, they bubble it through seawater like a mineralization process, and create cement with it. So normally where you emit 1 ton of CO2 to create 1 ton of Portland cement, Blue Planet is taking CO2 to create cement. It's totally turning upside down the equation. Nature makes use of abundant materials. Less costly, makes sense. And New Light is another company that is also taking carbon and also methane to create bioplastics. So they take out the air pollution, they take out the greenhouse gases, they put it in a reactor, add a biocatalyst, isolate the different particles, different streams, and then repolymerize them to create a bioplastic. And they're doing great. They have lots of deals with big companies like IKEA. So maybe your next plastic thingy from IKEA could be made from air pollution. And here's another one. Ecovative is making biodegradable and compostable packaging out of mycelium, out of fungi. They grow it and use it as packaging material that you can, after use, just put in your bin, put it on your compost. And they have made grown molded shapes. They make large panels and blocks that are really firm and can be used also for isolation in homes. And they make high-performing foams, all from mycelium. So one big lesson that we can take from nature is that nature works with just a small subset of elements. Carbon, hydrogen, nitrogen, and oxygen can be found in all organisms, and the lower you go in the lines, in fewer organisms you will find the elements, also in fewer amounts. So we can tap ourselves on the shoulder that we have great recycling programs for, I don't know, let's say aluminum. But shouldn't we be looking at the larger picture? Shouldn't we try to mimic the Lego style of nature to create materials instead of making a new polymer just because we can? It makes it much easier to take them apart and reuse them and reconfigure them for new combinations and new materials and functions. So finally, I like to address some time to interface as a case, because they use biomimicry really as a strategic framework for conducting business in the circular economy. And they, first of all, let me give an overview of where they come from and where they're going now. So back in the mid-90s, they were just a regular fossil-based company making carpet tiles. And at some point, they set themselves the big goal of having no negative impact by 2020. And they did. They reached their big Mount sustainability. And from now on, they're starting to work to become a regenerative business. So what did they do? Well, first of all, they translated some biomimetic principles into high-level business strategies. They wanted to eliminate all forms of waste in every area of their business. They want to have benign emissions and eliminate all toxic substances. They want 100% of their facilities to operate on renewable energy. They started to redesign processes and products to close the technical loop through the use of reclaimed and bio-based materials. Also, they put some attention on moving people and products around efficiently to reduce waste and emissions. And they had two more social strategies. One was to create a sustainability culture within their own company, but also amongst their stakeholders. And finally, they really want to create a business model that demonstrates and supports the value of doing sustainability-based commerce. And in their journey, they also made use of biomimicry for some of their innovations. Their first big success was Entropy carpet tiles that took inspiration from a forest floor where you can see a random design. Until then, all carpet tiles had to be exactly the same color, same flow of hairs. But now that they start taking notion of that random design concept, not all carpet tiles had to be the same anymore, which made it much easier to install them. Less time to put them down because it didn't matter anymore. There was less cutting waste. It was much easier to replace them. They didn't need as much stock because you didn't have the different dye paths anymore. So again, lots of benefits and 40% turnover very quickly. So with that success in mind, they turned to nature again to come up with solutions for their next big problem, which is normally carpet tiles are glued to the floor. But our glues have lots of VOC emissions, meaning that it's unhealthy for the people that install them, but also for the occupants. So they started thinking about how does nature adhere temporarily? How does nature stick things together? And they quickly thought about the gecko, who by having tiny million hairs can adhere itself to walls and climb on ceilings even. But they also figured out that nature doesn't really stick together very large interfaces. So they rephrased their question and asked themselves, how does nature keep things to the ground? And then, eureka, gravity. So what they did now is they developed tactiles, which are post-it note size connectors that function the same as the gecko feet and can hold up together 4 carpet tiles, which makes them heavier so gravity can do its work. Of course, Interface also has a big the take-back program, a recycling program. But they wanted to take it one step further. They started thinking about, if nature works with abundant materials, what else can we use? And they found out that fishing nets that are thrown overboard because there's a hole in them or something, that they consist of a really high quality nylon that they can use for their carpet tiles. So now they collaborate with NGOs and fishermen in the Philippines who cannot fish on fish anymore because of overregulation, fishing overregulation, but now fish on fishing nets, sunken fishing nets, make an income by selling them to Interface, who can use it again for making their carpet tiles. So with that, they're cleaning up the ocean floor, helping to save marine life, and making an income in developing countries. Well, as I said, it's 2020, they reached their Mount Sustainability goal, and now it's time to start moving towards becoming a regenerative business. And they committed to a huge Apollo project called Factories as a Forest, together with Biomimicry 3.8. And the thinking behind this is that ecosystems are very generous. They provide all sorts of services to everything that lives within the natural ecosystem. And taking that notion, how can our buildings and schools and factories and cities even do the same? So for this, it is really taking nature not only as a model, but also as a measure, taking nature as a benchmark for your business performance. And answering the question, can business also provide ecosystem services? So we get this, it's a mindset of giving back and not just taking. So that's what Interface started doing. Create a business that meets not only financial KPIs or whatever, but also ecological performance standards. And they are using some metrics of original biological ecosystems as their business benchmark. And those metrics can be many different things. It could be about water collection or water or air purification. It could be something to support biodiversity or building soil. It can be many things. Many things can be measured or are already measured, and they use that as a business performance benchmark. So Biomimicry 3.8 developed this process where first step, you start identifying your local reference in the ecosystem. Then you quantify the performance of the ecosystem, and that is your benchmark. Then you start seeing where the gap is between current performance, and you start creating design strategies. Again, of course, based on inspirations from nature, looking how local organisms deal with the situation in that ecosystem. And then we implement the design strategies so businesses can become a regenerative business. And this is being picked up by a growing number of business. In the US, they are already connecting with companies like this. And here in the Netherlands, we are starting to do the same. We've launched our Project Positive Netherlands to help and inspire businesses to innovate like nature and move to a really regenerative business. And if that is something that you are enthusiast about as I am, and if you want to embark on that journey, and mind you, it doesn't have to take as long as Interface, because now we know how to do it. If you are willing to think about it and take the first step in that direction, then please send me an email. And for the first 20 businesses that approach me, I will take out my time, half an hour of my time to do an intake, see where we can help you, and let's get this movement started over here as well. Thank you very much. I hope you enjoyed it.